All right, I'm gonna go ahead and get started. So today we're gonna do shape optimization, and we'll go over that in a little bit of what that is. Just really quick. There's the attendance QR code if you guys want to fill it out. Like normal, we'll send it out later as well in Slack.
Sounds good. Okay, I should get it.
Okay. So why do we want to do shape optimization on our parts and run this specific study? So there's a lot of reasons one would do shape optimization. Most of them are kind of more pertinent to manufacturing and mass producing models or parts that you're going to be creating. And shape optimization can reduce material. We'll go over how much material and how you can do that in Fusion in a second. And then it can also reduce manufacturing time because with less material, there's less you need to cut from stock, as well as several other things such as less material 3D printer actually needs to put out. And then it also improves productivity. With less material and reducing manufacturing time, you can produce more quicker and usually higher quality, higher or the same quality as before. So how does shape optimization specifically work? So basically a 3D model is subject to one specific type of study. In our case, that's going to be static stress. You can do this with most, if not all of the studies on Fusion 360. And basically doing this step allows the computer to understand what's actually going on in that model. So with the conditions you specify, the constraints and the loads, it can kind of really understand what would be happening in a real life scenario through the static stress study. And with that, it's able to kind of optimize and create this mesh that's the output of the shape optimization. And this mesh kind of represents the useful portions of the actual component, the kind of really crucial parts that are actually holding that force and that load under those specified conditions. And one thing that's really important to note is that the mesh needs to be really refined and really improved for you to be able to actually run shape optimization. That's why we went through all of this different settings last week and kind of worked through really understanding what the different settings can do with the mesh. Now, this doesn't mean you're going to run like all the super fine mesh settings. It just means you're going to run what's adequate for that specific model. And with that, the actual model, the mesh that comes out can then be kind of overlaid onto the original model, and you can modify it from there, and we'll show how to do that. So the actual steps, I'm going to go ahead and just go straight to Fusion so you guys can follow along. So the steps, obviously you're going to go to the simulation tab like normal. And you're going to go down here to shape optimization. It's this one right in the middle on the bottom. You're going to go ahead and create study. So with that, you're going to want to go ahead and assign your material. Go ahead and do aluminum, which you've been doing before. Let it take a second there. Okay. Next, you're going to want to go ahead and do the normal constraints and loads that you've done before. So we're going to go ahead and fix the constraint on the bigger hole on the interface of it. And then we're going to go ahead and do a force with an angle of 180 degrees in the X direction, 10,000 newtons in the interface of the smaller hole. Go slow with this. So once you've done that, you can move on to adjusting the mesh. And the mesh that I'm going to use for this specific simulation that we're about to run is a 1% model base size with 10 degrees on the turn angles. And then I'm going to go ahead and generate the mesh and leave all other settings on default. 10. Just leave it there for 1 second. So it's going to give you that same like error that you guys got last week, just go ahead and hit yes. We know it's a fine mesh, but that's okay. So next, you're going to want to define the shape optimization settings, and we'll go over what each of these specifically is in 1 second. But basically, you're going to want a target mass of below or equal to 30%. You're going to want to maximize the stiffness of the part, and then you're going to want your minimum member size to be 2.256 millimeters or above. And this is optional because this is actually the default value in Fusion. So you'll see here in 1 second, I'll show you where the shape optimization settings are. So if you go to your tree here, you're going to have one new thing, and it's going to say shape optimization settings. So basically, you can go ahead and hit the little edit button here, and this prompt will pop up. And the two that I mentioned initially are right here, target mass and stiffness. We actually are not going to change them right now, but for your assignment, what you're going to be changing is this target mass. So basically what target mass is, it specifies how much of that original mass do you want left over in the part. So for example, for this right here, we're going to want 30% or more of the mass to actually be in the part at the end. And then the stiffness is basically just we're going to maximize the stiffness of the part. You can make parts that are not as stiff if you want them to bend or something of the sort. And then the minimum member size, you actually are going to have to go ahead and click this little plus in the global constraints right here. And it'll pop up here. You'll see it's default to 2.256. Basically what this specifies is when the computer is going down and kind of cutting at your model per se, it's going to kind of keep this as a minimum bound value for any part on the actual model. So if you don't want, say, this middle part to be too thin, the minimum that it will actually ever be with the simulation set at this will be 2.256. When we actually run this simulation, I don't think any part of the model should hit this, but it's just something to keep in mind. I'm going to go ahead and delete that because we don't actually need it for the simulation. It's just kind of in the background there on Fusion. And then from there, you can go ahead and hit OK. So next part is you basically run the simulation. This takes a little bit. So I'm going to go ahead and make sure it's all good, and then just go ahead and run it. Also, this is a good thing to note. If you are not using your educational account right now, you will not be able to run this study. Shape optimization requires cloud credits, which is something that the Purdue like Fusion account provides for us. I believe you have an unlimited amount. Yes, you have. Yeah, it says unlimited amount there. So you have an unlimited amount of cloud credits. This is like kind of like a way for Fusion to monetize the program. Yeah.
Like the Purdue EU investment.
Okay, I'll be right there in a second. And then so yeah, so you basically just need to make sure you're on the Purdue account, and then you should be able to run it. If you have any issues, again, just ask us. But I'm gonna go ahead and hit run on that. And then while that's running, I can answer questions or anything like that. We're gonna wait for a second. I'm gonna go ahead and just show how I actually solved that error really fast, because that can happen and it's pretty common. Even if you're on your Purdue account, sometimes it doesn't recognize that it needs or that it has kind of cloud credits. So what you're gonna have to go and do, this may not be for everyone. Most of the times it's already fine. So you're gonna go ahead and go to preferences. And then if you go to simulation and generative, or sorry, tokens and cloud credits right here. And then you go down right here for your simulation tasks and generative design tasks, make sure that it says education and not the other one. Cause so like the other one's my personal account and then the education is the Purdue account. Cause you should have an unlimited amount of cloud credits and then just go ahead and hit either apply or okay, and it'll close. And then from there you can run your simulation like normal. Okay, I'm gonna go ahead and keep going through it. So once your guys' simulation is done, you can just go ahead and hit close on that. So this is basically the results section for the shape optimization. It looks very similar to the normal static stress with the difference that you have kind of this weird looking shape on screen. So this basically represents the 30% of the original model that's left over that Fusion is indicating, hey, like, hey, this is enough to actually handle the load you want to apply to it. And what you can do here is the red parts are kind of the most crucial parts. You don't really want to be removing too much, if any at all, from there. And then kind of going out from that, yellow and green is stuff that's kind of more non-essential. There's actually blue on here. It's just not even showing up because it's just simply remove that. I'll show that in 1 second. So if you go to this slider bar here, there's two things you can see below it. It's the approximate mass and then the mass ratio. So right now it's set to 30.94%. So that's how much is left from the original model. And then if you grab this bottom flag right here, you can actually drag it and see what it would be like if you left, say, 40% of the original model. And you can see the blue start to come in there. Obviously, if you go to 100%, that's just the original model. And then you can similarly do the opposite. So you can grab the top flag and you can, if you were to say leave it all the way at the bottom, and you were to grab and kind of remove the most crucial parts, you can kind of see the outline of where that is from when you remove it. So for now, I'm going to go ahead and leave this to just somewhere around the target, which I think it was right there. So once you've done that, you're going to want to go ahead and go back here. Okay, so you're going to want to go ahead and go to your results tab. And in the results tab, you're going to see something called promote. It's also up here in this little icon. Go ahead and click on promote. And basically what promote is going to do, it's going to pull up this prompt. And the actual presentation here says that you're supposed to add it to the existing simulation model. So if you do this, you're actually going to change the simulation model currently in there. But we're going to encourage you guys not to do that, because that would mean you have to kind of copy and paste this file, or copy and paste the original file with the actual model over and over again for your assignments and do it on every separate one. Or what you can do is you can go ahead and clone the current simulation model. And then that kind of creates like a separate one where you can mess around with it. Go ahead and hit OK. So this should pop up. So as you can see, we have our original model kind of on the outside there, and we have the mesh that Fusion generated on the inside, and it's kind of overlaid one on top of the other. So what you're going to want to do at this point is you're going to want to go ahead and hit create sketch. So what we're doing right now is we're in the simplify kind of mode of Fusion, and you can basically go ahead and sketch out the parts that you don't need and then do a cut extrude on it. So that way you're basically modifying the original model to fit what Fusion thinks is the right model for the actual part and the conditions specified. So I'm going to go ahead and do that. Also, the mesh is very bumpy, as you can see. We try to get as close to it as possible. It doesn't need to be like, you don't need to zoom in and do every tiny little line, but try to keep within as close as you can to it. So for example, I will go like there. Yeah, if so, like the ones that you're gonna cut, so like this one, for example, is one that we're gonna cut. It needs to be a closed loop or else it won't allow you to cut it. Yeah. So then there's this, there should be this side one here, and then the middle one, and the ones right here. Just as the entire. Yeah, and it doesn't need to be super exact. Like you can see here, I kind of overshot the arc as much as I could just so it wouldn't be cut. Yeah, I'm gonna keep going through it. So once you finish your sketch, you can go ahead and just hit finish sketch. And then in this create, you're just gonna simply do extrude and then make sure you select cut and then choose those specific parts that you're gonna cut. And then go ahead and do distance to object. And then I'm just gonna select the bottom face of that model and then go ahead and hit cut. Yeah. Yeah. Can you try deleting that?
It is clear though, but it's really one. Oh, that would be it. Right. So, if this line is really, it's just. Like some. But it's interesting. Is in this country. Let's finish this. The next part, you don't really have this. You just basically finish this. So I'll come back once we finish. Sure. Yeah. You may want to try. I've had this happen before, and then I just kind of deleted their sketch. So I didn't do it. Yeah. Because sometimes that will happen. Yeah. What? Yeah. Okay. Hold on. Okay, could you try clicking the operator view button to switch that? Yeah. I did that. Here's what I'm trying to see. Your schedule's a little different. There's a and then try to do this. No. I see. Try to change that. I think we're using. Yeah. Okay, I'm gonna keep going and then we'll go back and do the sketch in 1 second. So once you have that completed and your cut extrude done, you're gonna want to go ahead and go into this modify right here. So like we talked about before, sharp faces actually cause a lot of issues when you're dealing with a kind of load applied to it. So what we're gonna want to do is we're gonna want to go ahead and fill it kind of the main sharp edges around the model. So like this one here, there, that inner corner right here. Here and there. I'm just gonna leave it like that for now. So Then what you're gonna wanna do after you fillet your edges, I didn't actually finish filleting, and then my sketch had a little issue up here, as you can see. You just go ahead and do finish simplify. At this point, your model is changed. So your original model can still be seen in the design, but if you go back into simulation, your model is changed for the specific simulation. And from this, you can actually go ahead and hit create study and then do another static stress study on this. You're going to see that the results should be above 1. If they are not, if the safety factor is not above 1, that means you removed too much from the part and that you need to go back and either modify your sketch or modify the parameters of the actual shape optimization. So say you remove 30%, you can see that that is too much and the part's actually going to fail when you do it now. You're going to want to go ahead and say maybe do 40% mass. So I'm going to go ahead and just set up a quick static study stress like we've done before with the loads we had specified previously, constraining the big face, putting a 1,000 or 10,000 newt load on the inner hole. And then when you do this, make sure your mesh is set to the same amount that it was before. So I'm going to go ahead and change it to 1% and then 10 on the curves. And then go ahead and hit solve on that. And while that's solving, I'm going to go ahead and actually show the result of what it would be like once you finish the simulation. So here you can see that this is a 30%. Depending on how you do your sketches, your safety factor should be below 1. There are a couple configurations of sketches that would make it not 1 or make it not below 1. So which would be acceptable. So this one you can see here that this part would fail along the red parts shown right here, this one right here, and then in this inner hole, and then right here. And as you can see, there's one big thing in common with 2 of the 3 spots where it breaks. This part is actually not filleted on those sharp corners from before. So the load is actually applied more and has more of an effect there. And so that's why we kind of don't really want sharp edges in our model. So see, this is one of the configurations where the safety factor is above 1. It's just really nicely cut. The ones I did over there were done kind of really fast. So I'm going to run through the assignment really fast, and then I'll go back and help those who need help. So the assignment is basically doing the exact same thing we just did in lecture today. The 30% one is actually the lecture one that we did. So you've kind of covered that one already. And basically what we need from you guys is we need you guys to run the shape optimization for 20% target mass, 30 and 40. And from those, optimize the mesh and then run the static stress on that new improved mesh you created. And then with that, provide the 3 screenshots of the simulations or of the static stress simulation you have provided before, the displacement, the safety factor, and the stress. And then it should be a total of 9 screenshots. And then for this, for the shape optimization, you can go ahead and the static stress studies, you can go ahead and just run the mesh with the 1% and the 10 degrees on the curves. Yeah, that's it. I'm going to go back around and help those who need help. And I'm gonna go ahead and just on screen really fast, but send it out later too.